Hey everyone, here is the next example for trig and for trig with secant and tangent. So I've got a secant squared, I've got a tangent cubed, or secant to the fourth and tangent cubed. These three x's don't really matter too much except for when I actually am taking the integral. I'm probably going to need a 1/3 out in front, so don't forget that part. So you think, okay, am I going to have secant or am I going to have tangent as kind of my u, and then what do I have? Well, I know that tangent x equals c, or the derivative of tangent x equals secant squared. So I think, what could I do? Do I want to do it this way, or do I want to have secant tangent as my du? So if I have secant tangent, then I'm going to take both these down a power. I'm going to have tangent squared, secant to the third. I don't know if that's going to work great. It might work out, but I've got a different way to do it. I'm going to try and use this. So I'm going to try and have everything in terms of tangent. All right, but that means I need a secant squared. So I need to pull out a secant squared out of this part, which I think will actually make sense because I'm left with the secant squared. So we can say this is going to be the same as secant squared of 3x tangent cubed 3x, and then I've got a secant squared dx, which I kind of say secant squared x dx. This is going to be my du, right? So what I wanted to say is u is probably going to be tangent of 3x, and then I can say du, oops, and that should be a secant of 3x, sorry, du is going to be secant squared 3x dx. Alright, so that means I have to get everything on in this part. Let's just change that to a different color here. Let's say everything in this part should be in terms of tangent. Okay, so can I do that? Can I change secant squared to tangent? Well, of course I can if I know the formula for it, which we can actually go back. Let's go back here and say, remember, tangent squared plus 1 equals secant squared. Okay, so this means I can just rewrite this as the integral of tangent squared 3x plus 1, let's put that in there, times tangent cubed 3x. Alright, and then we've got our dx over here, which is secant squared 3x dx. Okay, so next let's just distribute this whole thing and see what we get. Square and a cube, we can say that's going to be the same as, let's just put this back into red here, we can say that's the same as tangent, or multiplying, or should be adding, tangent to the fifth 3x plus tangent cubed 3x, and then we've got the secant squared 3x, secant squared 3x dx. Alright, so then if we say u equals that, the u equals this would be the same as saying this would be the integral of u to the fifth plus u to the third du. Alright, now here's the only thing, actually the derivative of this is going to be 1/3 because we have to take, or it should be 3. It should be 3 and we want it to be 1, so we have to divide everything by 3. Sorry, because we have to take derivative of tangent of 3x and then the derivative of 3x, which is just 3. So we'd end up with an extra 3 out in front here, so we have to divide both sides by 3. That way we'll get this. So we can say this is the same as 1/3 of all this. So then what we should be able to get for our answer, it should be 1/3 of, then we'd say 1/4 tangent of to the fourth 3x plus, let's see, what else do we have here? Tangent, hold on, let me see this. It should be 1/3 u to the sixth over 6 plus u to the fourth over 4 plus c, and then we can rewrite that as 1/3 tangent to the sixth 3x over 6 plus tangent to the fourth 3x over 4 plus c. And then if you wanted to rewrite this all, you could, I'm sure, with multiply both sides by, or distribute the 1/3. Right, so the last one, maybe I can write this legibly, would be tangent to the sixth 3x over 18 plus tangent to the fourth 3x over 12 plus c. Alright, there you go. So there is that one. Let's go on to the next spot right here. Let's evaluate tangent to the fourth dx. Okay, and you say, Well, what do I do here? Well, I would say here, let's just break up tangent into tangent squared and then tangent squared, and we can rewrite tangent squared as, do you remember what it is? It's actually right here. Tangent squared plus 1 equals secant squared. So we can say tangent squared, and let's just do secant squared minus 1. Let's see what that gives us. So if I take this integral, I'm going to forget about the constraints in here. I'm just going to make it an indefinite integral, and then we'll just put those in later. So I'm going to say this is going to be tangent squared x times secant squared x minus 1 dx. Alright? So you say, now what do I do? That's a little bit better. Do I want to write it in terms of sine? Or in cosine, or tangent, or secant? So I'll just kind of see where this goes. What I want to do here is maybe we should distribute this tangent squared. So let's take this and say that's the integral of tangent squared x, there we go, secant squared x minus tangent squared x dx. Right? Okay, sounds good. So now I know if I make u equal to tangent, then I know du is going to equal secant squared x and x, right? So this one seems to be really good shape, so I can just write this part of it at least, right? So I can rewrite this one as, this is going to be the integral of u squared du minus the integral of tangent squared x dx, right? So if I get tangent squared dx, I can just rewrite this one as secant squared x minus 1, right? Because that might make it a little bit easier. So I'm going to actually just rewrite this part as the integral of secant squared x minus 1 dx. Okay, because do I know what the derivative or the integral of secant squared x is? I do know what that is. It's just tangent. So therefore, because it's kind of like going backwards from here, so I know what secant squared is. It's just tangent. So if I know the derivative of tangent, I know the integral of secant squared. So that makes this quite a bit easier. So I can say this is really 1/3 u cubed, right? Which is u is just tangent squared, or just tangent. So we can say 1/3 of tangent cubed x, and then plus the derivative of secant squared is just tangent x, and the derivative of -1 is just going to be x. And then we're going to evaluate that from 0 to pi over 4. So if I plug in pi over 4 into all of these, I should end up with an answer of about pi over 4 minus 2/3. So if you plug that into your calculator, you should also get about 0.119. Alright, so there you go. So we might have to break this up into multiple parts. Do this once, and then twice, and then break this one down further, right? Because we broke it down even further, and then that might make it a little bit easier for you. Alright, so there you go. Here is the last one we're going to look at. If we have secant x over tan x, we're going to find the integral of that. We don't always have to rewrite this in terms of just secants and tangents. So I say, well, I know derivative of tangent is secant squared. I don't have one of those. Derivative of secant is secant tangent. I don't have any extras that I can really pull out or move around. I can rewrite this all as terms of secant. But maybe we can do something else. Remember what secant is? That's right. It's 1 over cosine. And what's tangent? So I can really say this is like 1 over cosine x. And tangent squared is just sine squared over cosine. Or cosine squared over sine squared. Oops. Well, it's sine squared over cosine squared, but since it's in the denominator, we can say this is going to be cosine squared over sine squared x and x. And then we have the dx, right? Because I'm writing, really this is like the flip version of tangent, so I don't have to write a double fraction. Alright, so the cosine x and cosine x, well, this one just cancels out and the square goes away. So I'm left with really just the integral of cosine x times 1 over sine squared x dx, right? And so now do we know what the derivative of sine is? Well, it's cosine, right? So we can say derivative of sine is cosine. Let's just see what happens, okay? So we can just say, let's say u equals sine x, and then du is going to equal cosine x dx, right? So hey, I've got the cosine x dx right here, so I can just say this is going to equal the integral of u to the -2nd du, right? So that means I can say this is the same as -1 u to the -1st plus c. Right, so then let's just rewrite that. That's going to equal negative sine x to the negative first plus c. And 1 over sine, if I can want to rewrite that a little bit better, I can say this is the same as, oops, let's not do a double equal sign. That looks kind of weird. We can just say this is going to be negative cosecant x plus c, right? Because 1 over sine is the same as cosecant. So that would be your solution for this. There you go.